Good day, fellow. Setso is back. Today we are going to do some theorem. Firstly, let me just define to you the term theorem. The term theorem is just a general proposition which can be proven, which can be proven using logical reasons. See, but as for today, we are going to prove theorem 1, which states the line segment drawn from center to the midpoint of chord bisect the chord. See, then I'm going to give you this diagram like this. Okay, you see, sorry, there A, M, B together with O. Then let us write some requirements. They gave us that AM is equals to, say, BM. AM is equal to BM. As we must prove that OM is perpendicular to AB. We must prove that OM is perpendicular to AB. Somehow, if AM is equals to BM, therefore OM is going to be perpendicular to AB. But for now, we must prove that it is perpendicular. How? We are going to construct by joining, let's join OA and OB. Then we also construct on our diagram there. Then now we have constructed. Let's see if you can look carefully. We have two triangles, OAM together with OMB. We have two triangles. Let me mark as well here. We have two triangles. In these triangle, let's say AOM and triangle BOM. We must prove the congruence. Firstly, that's what we must prove. Firstly, see? Then for us to prove the congruency, let us see how are we going to prove for congruency. Don't forget the term congruency it refers to maybe two shapes which are identically equal. You see, you'll still remember those conditions. We have side, angle, side, RHS, angle, side. You see, then we must prove one of these conditions for us to see that these two triangles, this one and this one, they are congruent. Firstly, we're going to say now, from our given diagram there, we can clearly see that OA is going to be equals to what? To OB. You see, we have constructed what now? Radii. Then our reason is going to be radii. We have joined OA as well as OB. Those are radii. Then they are going to be equal as well. You see, then AM is going to be equals to BM. The reason already given. See, And let us move to the last one. Check. I have two triangles. You see OM, it appears in both triangles. Now for OM is going to be equal to OM, same. But the reason is going to be what? Come on. See? If you can look carefully, so far I have highlighted what? Only sides. Sides, sides, sides. You see? Then this condition is true now. Then from here we are going to say triangle AOM is congruent to triangle BOM. By saying so, we open bracket, then we say we get this condition whereby now all the sides of this triangle, they are congruent to the other triangle. But at this point, we haven't yet completed our proof. Let us continue now. Check. I'm going to mark 1 and 2 there. Mark 1 and 2. I don't have enough space, but let me try. Okay. From our given diagram, we can clearly see that angle M1 together with angle M2, when we add them, we must get 180 degrees. The reason for this, angle on a straight line. Straight line. See? It's true. But now check. Check. M1, angle M1 must be equal to angle M2. Why? Because now these two triangles are what? They are congruent. They are exactly the same. You see? They are exactly the same. Even their corresponding angles, they must be equal. Then I'm going to write congruence of triangle. Then at this point, where I see M1 or where I see M2, I can just substitute M1, or where I see M1, I can just substitute M2. Then it's going to be let's say M1 plus, I decide to substitute M1 here. M1 is equals to 180 degrees. You see? I'm going to continue just here for us to see everything. Now check. I have M1 together with M1. They are going to add up to 2 angle M1, which is equals to 180 degrees. When we divide both sides by 2, we get 90 degrees, which is M1. At this point, we can clearly see, oh, now we see that M1 is 90, M2 is going to be 90. Therefore, it's true that OM perpendicular to A, B. See? Let us proceed. Then at this point, I'm going to do a quick summary. If they give you something like this, whereby let's say A, M, B with O, we can clearly see that AM is equals to BM. Therefore, we already proved somehow that OM is going to be perpendicular to B, let's say AB. Your reason now is going to be line drawn from center to midpoint of chord. See, midpoint of the chord. We also have what? The converse, which is like this now. Let's say if I had now perpendicular somewhere there. See, now I have a perpendicular. If now I have a perpendicular OM, which is perpendicular to AB, then now it's also true that AM is going to be equals to BM. The reason for this one, you must say it's perpendicular from center to the chord. See, let us do some application. Suppose if I give you a diagram like this. Let's say I give you something like this. See, let's say I give you A, M, B. Then I say to you, I have O somewhere here. Then I give you somewhere there that OM, let's say, is 3. Then I also give you that A, B is equals to, let's say, 8. Then they mark like this on your diagram that AM is equals to BM. Then the question now which follows is find OB. How are you going to find OB? Check. It's so simple, not difficult. Then they said to us that AM is equals to MB. This one is given. You see, AM is equals to, let's say, BM. This one is given. You see, therefore, at this point we know that each will be equals to 4. You see, will be equals to 4. Or you can just do it like this. It's also fine. That we know that AM plus BM is equals to AB. Our AB is 8. At this point, I can just replace this with BM. See, BM plus BM. I do it step by step. And I'm going to have 2BM, which is 8. If I divide throughout, I'm going to get BM to be 4. See? It's not that difficult. Then now, I'm going to mark 4. I'm going to mark 3. For us to get OB, we must make sure that it's 90 degrees here. But at this point, we haven't stated that it's 90 there. But we know that our AM is equals to BM. Do you still remember that first theorem? We are then going to say, oh, we see that these two, they are equal. Then our O is going to be perpendicular to AB. The reason, oh, I don't have some space. The reason here is going to be line drawn from center to midpoint of chord. See? Then we can now use what? The theorem of Pythagoras. Because we can see now that at this point we should make a 90 degrees. Then we are going to use this one now, OB squared, which is, let's say, OM squared plus BM squared. At this point we get what? The theorem of what? Of Pythagoras. Then our OB is 3 squared. Then our BM is going to be 4 squared. Then we get 9. 9 plus 16, we get 9. We get 9 plus 16. Let me check my calculator. Okay. Okay. Let's see. It's going to be 9 plus 16. 25. 25. Sorry. OB squared. For us to find the value of OB, we take what? A square both sides. And our OB is going to be 5 units. You see? Then can then say 5. Thank you. Enjoy.